right, so the first thing you can do is cross out this remainder theorem. This is relating to something that we didn't talk about where you can plug into functions and stuff like that. So you don't need to know that. What you really just need to know is how to use synthetic division in order to divide these two, okay? So you can cross that out and move on to this next part. Okay, where we are using synthetic division, okay? We are dividing this polynomial by this polynomial, and if you remember in the definition it said x minus k, okay? So that's that binomial, x plus or minus a number, okay? Well, when you set up synthetic division, if you notice, I dropped all exponents, okay? And all I care about are the coefficients. Now, I do need to make sure, here's a 3, a 2, there's an automatic 1 there, and then this doesn't have, it's actually like a 0. So as long as I have a term for each exponent, then I don't need to include that 0 like I did last time. And then all we did was, this had a 1 in front of it, so I put a 1 right there. The 4 went right here. The negative 5 goes right there. And the positive 3 goes right there. Okay? So I'm just taking these coefficients and putting them in an upside down box is really what it looks like. Okay? And then the other part of this is that we take the number here and we put the opposite on the outside of the box, okay? So put the opposite over here. Okay, and that's because it relates actually to factors. If you remember when we were solving, when you would get a factor, when you solved it, you used the opposite. That's what we were just doing last class, where we were saying, oh, well, if the factor is x plus 3, then when I solve it, it's x equals negative 3. It's the opposite. So if you've got a plus 2 here, you actually want to use the solution here. You want to do the opposite, so that's why it's a negative 2. Okay? So that's how we set it up. Then you just do, some students call it a boot, okay? You just do the upside down box. Okay, another thing I've seen teachers do is they take and they kind of separate this last line off, and you'll see why in a second, because this last line is our remainder, okay? And again, it's just kind of like how we use the box to multiply and to factor. This is just a way to organize, but it goes a lot faster, okay? So, we start with the 1, because that was the leading coefficient, and we bring it down. So there's a 1 there, okay? Then we multiply negative 2 times 1, and we put it here. So we go from here to here, and we multiply. Put a little times right there, okay? Actually, let me put a little times right. Yeah, I'll put it here, okay? All right, and then, now that negative 2 times 1 is negative 2, now you add these two lines up. 4 and negative 2 is a positive 2. Okay? Then you do it again, and you say, okay, well, since I multiplied the first time, let me now say negative 2 times 2. So let me erase this. And now let's look at the next one. Let me erase that too. All right? So negative 2 times 2 is negative 4, and I put it right here. So I multiply negative 2 times 2, and I get negative 4. So I'm always multiplying this times the bottom and bringing it into the next line. And then again, you add these. Negative 5 plus negative 4 is negative 9. Then I follow it again, and I say, okay, now let me multiply negative 2 times the negative 9, so that's the new one. And I'm going to put that number here. So negative 2 times negative 9 is 18. And again, now I add these two up, and I get 21. Okay? So it's multiplied each of those, and then add each of those. Okay? That's the process. And when you do it a few times, you get used to it. Okay? So now we actually have our answer, but it's just, you've just got to understand how to read it, how to take it out of this box. Okay? What happens is this last number, that's why we kind of boxed it off, this is our remainder. Okay, that's our remainder. So you're going to write it as 21 over over x plus 2, because that was what we were dividing by. Okay? Now our answer has to go back into a polynomial. We started with a polynomial, so our answer has to be written back as a polynomial with x's and x squareds and stuff. But these are the numbers of the answer. So, because we started with an x cubed, but we divided by an x, that actually means that this lowers each of the powers, okay? Now what I actually do, the way I think of it, is I actually just go backwards and I say, okay, well, if this was the remainder, that means this is the constant. That means this has an x, and that means this has an x squared. So I just go backwards. Remainder, the constant is in front of that, the x is in front of that, and the x squared. So if I had more, the x cubed would be in front of that, the x fourth would be in front of that. So you just go up. Or you could say x cubed divided by that x makes that go down 1, okay? So the final answer is 1x squared, or just x squared, plus 2x minus 9 plus that remainder that we already had, okay? So once you get the numbers, you just have to put the x's and the x squareds back into the right place. And it goes from the last one to the remainder, and then it builds up from there, okay? So that is synthetic division. So we'll do it another time in order just to get used to the system again. Okay, so hopefully you have that down. Alright, so let's do it again. It's kind of set up already for you. Okay, this rule says a polynomial has a factor x minus k if and only if, and instead of saying f of k, I want you to say r for remainder. If the remainder is 0. So if you get a 0 in that last corner, if you get a 0 on that last line, that means it actually factors, and then you can do more with it. So we're going to see that on this next problem, okay? So if the remainder is 0, then it factors. It's a factor, and a lot of times you can factor it more, okay? So now let's look at this one. Okay, so we know that this is a factor because it tells us. We want to actually factor this in a second, but we know that this one is a factor, which means we can divide it in there and it'll come out as a 0. It'll come out evenly. Okay, so because x minus 3 is a factor, you know that, and instead of this, let's just say the remainder is 0. You know that the remainder is 0. So we're going to use synthetic division to go through and find our numbers, and then we can factor it one more time, which is what we've been doing for the past few weeks. That's why we keep doing factoring. So let's look at this problem. Alright, let's just do the synthetic division part. So, we just took the coefficients of each one. It goes 3, 2, 1, 0. So, by the exponents is what I was looking at. So then I put a 2 here, a negative 11 here, the 3 here, and the 36 there. And then remember, whenever you fill in the front, it's the opposite of this factor, because you want to put the solution in there. So since this is negative 3, you want to put a positive 3 right there. Okay? So then you just go through the process, and the process is, let's see, the process is bring this down to a 2. Multiply those two. 3 times 2 is 6. Add those up. Negative 11 and 6 is negative 5. Multiply again. 3 times negative 5 is negative 15. Add those up, you get negative 12. Multiply again. 3 times negative 12 is negative 36. 36 and negative 36 is 0. That's exactly what we wanted. That's the whole thing of the fact of knowing that's a factor. That means that this last line, that remainder, is 0. So that means that I have a trinomial left. If this is the remainder, this is the constant, this has the x, and that has the x squared. Okay? So then this problem says, use the result to write as a product of two factors. So really what we're doing is we're going to factor this. Okay, so now that we have a remaining trinomial, there's no remainder, so it just looks like a trinomial like we're used to, we can actually factor that trinomial. I told you it doesn't go away. So, okay, so we're going to factor this trinomial. So let me scroll. Alright, so the last thing we're going to do, so far we know that x, what was it, minus 3 is a factor, and when we divided it, we got 2x squared minus 5x minus, what was it, 12. Okay, so far this is where we are. That was a factor, because they gave it to us. When we divided it, we got that as the other factor. And now we can factor this trinomial one more time. It's just kind of like going through your factor tree. It's a trinomial, and it's advanced. So what multiplies to negative 24, x squared, and what adds to negative 5x, okay? That is negative 8x and a positive 3x. So since it's advanced, we want to take it to our box. Okay, the more we do it, the more you're going to get used to it. So the beginning of the trinomial goes in here. The end of the trinomial goes in here. And now our new numbers go in there. So now let's just do the GCFs of the box, and we've got it. So the GCF here is 2x. GCF here is 3. Pardon me, GCF there is x. GCF here is a negative 4, and you always want to double check. That makes sense, that makes sense, that makes sense, and that makes sense. So, the final answer is x minus 3, and then the two binomials we just got out. 2x plus 3 and x minus 4. Okay, so again, it rolls right back around to factoring. So we divided, we used synthetic division to get this, but then again, it still goes back into factoring so that we can get that out. Now, this doesn't equal 0. We're not solving like we did last class. This is just taking division and relating it to factoring so we can finish out all of these polynomial operations, okay? So, I guess we're just going to keep practicing that. Okay, the next one's a little bit different, but it's pretty, we're going to do it the same way. And so then we're just going to have to factor and just keep practicing it, okay?